Hi everyone, and thank you for joining this webinar entitled Hybrid Cloud and What Does It Mean for You? This webinar is presented in conjunction with Kemp and NB Consult, and it's meant to be the first in a series of webinars about hybrid cloud offerings. And we'll ask you some questions at the end of this webinar to hear what you'd like to have more of. First, let me introduce myself. I'm a messaging consultant, and I spend most of my time on Exchange Online, or related technologies. I'm either architecting, implementing, migrating, or speaking about any of those. And in my spare time, I also contribute to blogs, I speak at conferences, and I co-author books about Exchange. It was a natural progression for the company I work for to move from on-premises Exchange to cloud-based versions. So we started building hosted Exchange for ISPs. We moved customers over to Office 365, and then we started consuming infrastructure services on behalf of our customers from providers like Microsoft and Amazon. After that, it became a natural progression for us to start building public clouds based on similar platforms. If you have any questions about this material, then please feel free to reach out to me directly using any of the contact details on this slide. However, this slide will be part of the recording as well in case this slide passes by too quickly. Let's define our agenda for today. We'll talk about defining what cloud is, we'll define hybrid cloud, and lastly we'll end off with some hybrid cloud usage scenarios. Let's dive in, and we'll start with our journey of defining hybrid cloud. Before we can go forward and talk about hybrid cloud, we need to look at where it came from and how it evolved. We need to start talking about how shared computing models started, since shared computing models aren't new. Mainframe and mini-computer platforms were able to offer a shared service concept since the 1950s. And in fact, when I speak to mainframe veterans, they like to comment about how we in fact are reinventing existing concepts, and that cloud as a concept isn't anything new. In the 1980s and 90s, we built data centers in which we applied the now traditional client-server model. This scaled really well to the limits of our budget, and it forced us to think about things like redundancy and disaster recovery. Then we hosted in other people's data centers. We either co-located servers in their data centers, which meant we rented space from them and put our servers or services in their data centers, or we started to buy the equivalent services from them without deploying anything of our own. Often that allowed us to pay per use, and we started thinking of the things we consumed as services like software as a service. Then we moved from the hosting term to the cloud term, which became a little bit confusing since we're talking about a layer of abstraction, which became a marketing term. Clouds, in effect, are a concept which allows us to virtualize all kinds of things, such as services, platforms, networks, storage, and other things, and they are abstracted to the point where we really don't care how they work, as long as the service they render is what we're expecting. We really don't care about how many hard drives are in the servers anymore. We now care about how fast email flows, or how large a database can become, and how many transactions per second it can perform. Clouds also tend to offer a layer of interfacing where we removed from the complications of the provisioning of the service. Often this means we have some kind of a portal that we interact with, which allows us to choose our services and either increase or decrease them on demand. We have further differentiators in clouds. As an industry, we started talking about public clouds, which were the kind of cloud principles we've been talking about. However, commercially available to the public to be consumed via some kind of a billing mechanism. This means we could pick a service that we need, pick a cloud vendor that offers the service, and then consume that service often over the internet. We also have another differentiator wherein we can build clouds in our own data centers. So that same layer of virtualization and abstraction, but for internal use only. Let's take infrastructure virtualization as an example. Let's assume we have a development team. They need a bunch of virtual machines for some kind of a task. Normally this means they would log a change request that is picked up by the virtualization administrator, and during the course of his or her day is actioned. If the virtual machine is the wrong size or the wrong configuration, the developer needs to log another change, and the workflow repeats itself as many times as is needed until our developer finally gets what they want. If we have an on-premises private cloud, we could offer the developer team an account to log into a kind of a service or a portal. This account would have predefined limits so the developer and the service is protected, and the developer can request and provision and deprovision virtual machines on demand without needing a human being to interact on their behalf to action the request. Our biggest takeaway here in terms of defining private cloud is that private clouds are still a bunch of virtualized services, normally with some kind of a nice portal interface, which allows for the consumption of whatever the cloud offers, except that it's a private and on-premises service. Generally within cloud-based services, we have three tiers. We have software as a service, we have platform as a service, and we have infrastructure as a service. Software as a service is exactly that. It's software, like SharePoint or Exchange or CRM as a service, available remotely, typically via the public internet. These tend to be on-demand applications that are hosted and managed by a service provider and typically paid for on a subscription basis. Platform as a service platform as a service speaks to platforms, which could be software or services platforms. These platforms often allow for development of applications or services in turn by providing platforms, languages, databases, and anything that you'd need to carve out your own service. We can think of Microsoft Azure, SAP, or SharePoint of examples of a platform as a service. Infrastructure as a service refers to the equivalent of infrastructure replacements. So think servers or storage, networking, as well as services such as load balancing or a content delivery network. As a principle, clouds are meant to be able to deliver more than an on-premise equivalent can and grow to accommodate further load. Clouds tend to be on demand, so both economically as well as in terms of delivery capability, which is what the elastic piece means. If a cloud offering comes to market, it should be able to handle many times more load than the on-premises equivalent service or be able to expand on demand. That allows us to overflow all kinds of services, but typically as an island of service. As an example, a virtual machine hosted in the cloud, which I have uploaded, or Exchange mailboxes hosted in a cloud service without any type of integration to anything on premises. This is where the fear of losing a job becomes really real, where software as a service or another type of service can in fact replace a person or group of people. If on-premises Exchange is replaced entirely by a service-based equivalent, then some of the team or the administrator may lose their position or do something else, since there's no need to monitor, to patch, or backup Exchange servers anymore. And this is where Doug, our administrator, is facing a very real chance of losing his position or even his job. In defining hybrid cloud, I've purposely brought in these two pictures, specifically a cloud and an anchor. Since it's a metaphor that translates well to the definition of hybrid cloud that I'm going to use. And my definition is any service that shares or extends an on-premises service into a cloud-based service. With the previous picture in mind, think of your on-premises data center consuming cloud-based service without disabling or switching off anything on premises. Think of your data center acting as the anchor to your business while extending the requirements that the business has into a cloud-based service. Hybrid cloud services economics are similar to cloud-based services, but we have a big difference. We still have CapEx versus OpEx, so capital expenditure versus operational expenditure, which means we can rent instead of buy. We can buy services on demand, which we can use to burst or overflow our requirements. These can still include virtualization or compute capacity, storage overflow for databases, files, unstructured data, or even extensions of services like service queuing or workflow scenarios. To make it practical, in a traditional compute cloud, I would create and consume a virtual machine. In a hybrid cloud, I realize I'm running out of steam on premises, and I migrate the virtual machine onto the cloud platform, scale it to the size I want, and run it from there. I could keep it there or migrate it back when I'm done. One of the big differences to Dave, our sysadmin, is that Dave now extends his infrastructure into the cloud on demand as he needs it, as opposed to replacing his on-premises infrastructure. One of the big deals in terms of hybrid cloud is that we are no longer replacing pieces of our business wholesale with the cloud-based equivalents. We are enhancing or augmenting it with cloud services. The last point here is transparency. The users of the system should not be burdened with the mechanics of this. Users store their files on something. That something uses a cloud-based mechanism to extend its own storage and retrieves the files the user needs on demand. The user shouldn't know about the mechanism or be impacted by the way that it works. Let's look at some examples from what we call the beginning of hybrid cloud. An example which a lot of the people in the Microsoft world are familiar with is Exchange Hybrid Mode. Exchange Online Hybrid Mode allows two Exchange organizations to appear to be one. This specifically is the Office 365 based Exchange organization and the on-premises Exchange organization. Normally we have a shared services scenario, and within this shared services scenario, which include things like FreeBusy, mailbox moves and so on, we have single sign-on as well. Other examples which are much lighter that we can relate with are cloud-based email hygiene. We can have anti-spam, antivirus, data leak protection, and other services from a cloud-based vendor which our on-premises Exchange organization consumes without hosting those services themselves. Something a little bit more on the storage side is cloud-based backup. However, cloud-based backup isn't new. We've been doing this for years. What we can do in a hybrid cloud example, though, is we could back up our SQL to hosted SQL, and in the event that our on-premises SQL fails for whatever reason, our hosted SQL or our cloud SQL transparently takes over and becomes available as a service. Let's continue looking at Exchange Online with hybrid mode. One of the provisos is that we have a single sign-on experience to the user. Let's assume we're using ADFS to accomplish that. ADFS could be load balanced between on-premises and cloud. That means that we'd need a persistent VPN to extend our on-premises network to a cloud provider's network. We would need a cloud-based domain controller to extend our on-premises Active Directory to the cloud-based Active Directory via a virtual machine. And of course, we need cloud-based ADFS servers. Now, in our scenario, we could either host all our ADFS servers up in the cloud, since we've got a persistent VPN, which allows Active Directory to replicate, or we could have an on-premises ADFS server and using a cloud-based load balancer, load balance between the on-premises ADFS server and the cloud-based equivalent. And while this sounds quite difficult and esoteric to do, it's as simple as rolling out a Kemp virtual machine in either Azure or AWS and pointing it via the two public records which correspond to the two ADFS instances and selecting the weighting that you would use in terms of do we prefer the cloud-based ADFS versus the on-premises ADFS or vice versa. Let's look at a storage example. We can overflow or extend an on-premises storage requirement using a storage appliances, and there's a few of those on the market. Those present an on-premises LUN which tiers not onto secondary storage but onto cloud storage. An example of this, for example, is the Microsoft Store Simple appliance, which tiers onto Azure Blob Storage. Amazon allow you to do the same thing using the AWS Storage Gateway, which extend to Amazon Simple Storage Services or Amazon Elastic Block Storage. Storage-specific vendors also allow you to tier onto services. For example, NetApp allow you to tier onto AWS directly. Identity is a huge piece of the puzzle as well. Identity as a service is offered by many cloud vendors, where identity can be used to authenticate to an application which we write. However, we no longer need to write the authentication piece. We can consume it. This means I could use a Facebook or some kind of other identity to log into an on-premises application with a cloud-based identity provider handing me the authentication and returning the required pieces to my application in order for the user to be recognized and authenticated. That means I don't need to write the Facebook piece in order for a Facebook user to authenticate to my application. How does virtualization fit into hybrid cloud? We've spoken about virtualization in the context of moving a virtual machine into the cloud and using it via the cloud-based service. Most of the time it doesn't really matter who your cloud provider is, as long as what you're running is supported by someone and that you're happy with how that support works. As an example of this, running Exchange, SQL, Oracle, or anything else on a hypervisor of some sort. This could be an on-premises hypervisor or a cloud-based hypervisor. Some examples that I've chosen, for example, are SAP and Oracle are certified to run on Hyper-V and Azure. VMware will support Oracle running on VMware. However, Oracle will not support Oracle running on VMware. Amazon via AWS will support some applications like Exchange. However, Microsoft currently do not support Exchange running on AWS. It's really easy to expand and consume cloud services, but it's also really important to understand who supports you should something break. Does that mean that hybrid cloud means data center on demand? And to a degree, yes, it does. We can consume as much or as little as we need, and the boundaries can become quite blurred depending on what we need. However, and this is a really big however, just because the provisioning of the service has become really easy doesn't mean that planning and common sense stops. Using our data center example, we still need to think about the many disciplines of running a service, planning outages, understanding disaster recovery, and so on. While cloud-based services make this much easier, and a contract could absolve you of a lot of the responsibility for that service, you still need to know where the limits are for what you're running. I like to say that irrespective of what you're building, if it's your own or if you are consuming someone else's services, you still need to build for failure. In conclusion, we've defined hybrid cloud as any service that shares or extends an on-premises service into a cloud-based service. We've spoken about software, platform, and infrastructure as a service. And we've looked briefly at a few examples which demonstrate hybrid cloud in these kinds of service scenarios. So what's next? Well, that depends on you. As I said in the beginning of this session, we'd like to do more of these webinars, but we need to know what you'd like to hear more of. If we could ask you to please take the time to fill in the feedback questionnaire so that we know what you liked and what you didn't like. We've proposed some possible topics such as how to start developing on cloud, or potentially deep diving into platform infrastructure or software as a service, but we really need to hear from you so that we know what to do next. We also have time to answer any questions if there are any.
Thank you so much, Nick. That was a fantastic webinar. Hopefully we'll have a couple of follow-up ones, as you mentioned, from the survey questions that will go out right after the webinar ends. We don't seem to have any questions right now, so if everybody could complete this survey for us, and we hope to see you again at the next webinar with Nicolas Blank. Thank you, Nick.
Thanks so much, Dee. Thank you everyone for joining.